All right, so here to talk to you guys today about Blaze and Odo. My name is Phillip Cloud. I work for Continuum Analytics. I spend part of my time doing open source, most of which goes towards Blaze and Odo, a little bit on Dask, and then pandas when something doesn't work in Blaze and Odo because of pandas, which is rare, but it does happen. All right, so let's just dive right in. Blaze. So what is Blaze? It's an interface for data-centric computation. It's composed of two things: expressions and compute recipes. What do those look like? Where does Blaze sort of sit in the PyData ecosystem? Many systems have a two-level architecture. They have an interface and they have an implementation. NumPy has an API that sits in Python, which wraps a lot of its low-level C code, operating directly at the byte level. Pandas has something similar, but instead of using C, it uses mostly Python. There's a bit of C for the CSV parser, but it's mostly in Python. But the user doesn't really see those Python bits. They kind of are only using data frames, series, which are all pure Python code. There's similar trends in other systems, right? You don't actually really delve into the details of your MySQL database or how MongoDB stores things. There's a language for it. In the SQL database case, it's SQL, and MongoDB has its own query language. And then numeric computing has something similar. And where Blaze is it's only an interface. It doesn't actually implement any computation. It just tells other systems what to do. Blaze is not a new idea, though it is the first thing that I'm aware of like it in Python. Postgres has something called foreign data wrappers, which let you write SQL and query things like a CSV file, or you can also, there's something called a C table, which is like a column store for Postgres, and you can write SQL statements against that. And it's not implemented by the folks at Postgres. It's a totally separate project. The closest thing to Blaze in another system is dplyr from R. And dplyr has this syntax where you can sort of chain operations together because the input to each function is essentially a data frame. And with dplyr, you can use things like SQL databases. There's a library in R called data.table, which is sort of like a data frame. And you can use standard R data frames. And then Python has something called SQL Alchemy, which most people in here are probably familiar. Who's heard of SQL Alchemy? Who's used SQL Alchemy? Okay, cool. So, and SQL Alchemy is kind of similar to Blaze, except that it only works with SQL. In fact, Blaze actually uses SQL Alchemy to work with SQL databases. So getting to the parts of Blaze, the first part is expressions, and those describe what you want to compute. And those expressions have two parts. They have to have a name, which is basically like a Python identifier. It's almost like a variable name. And they have something called the data shape. And data shape is another library that's a very small library, and it's an extension. It's sort of an extension of the ideas in the NumPy dtype system. So it lets you describe both the shape of an array or a table, as well as the types. And so in this case, we have a million row table with two columns, name column, which is a string, and amount, which is a float 64. So you can see below, I've annotated here, it says name, and then this is the shape information, typically like something you would get out of the NumPy ndarray.shape, and type information, which is basically dtype. Let me go back here. So data shape extends the dtype system to support things like missing values, variable length dimensions. it doesn't actually sort of tell those systems how to implement it, but it allows you to describe the metadata surrounding those ideas. There are multiple kinds of expressions. There's group by, there's join. We support all the sort of standard expressions that using Python syntax like arithmetic, data arithmetic, lots of reductions, very similar to pandas. We have like column and row stacking, and there are also others like isin and pandas. And so those are expressions. Then on the other side of that, you have the other part of Blaze. You have compute recipes, and these are basically saying, what do I do with the expression given a particular data source, like a data frame, a list of tuples, a SQL database, a PySpark data frame, and so on. And the way these things are written down is just like tiny little recipes that say, okay, I have this expression with these inputs. Now how do I do that computation? In this case, I'm doing join between two data frames, a pandas data frame, and of course, like the API for that in pandas is merge two data frames, and what you're going to merge on. Of course, there's a lot of other options to that as well. These are not actual implementations, but fairly close to the actual. And then when I'm getting two Spark data frames as input with a join expression, I call it slightly differently. So this one sort of thing that this alleviates you from having to do is learn a new API when you want to use a different technology. So maybe you want to experiment with your small scale data, doing some algorithm, maybe a SQL query, and then you're like, okay, well now I need to shove this thing into Spark and do it that way. These compute recipes work with existing libraries, like, of course, Python lists, numpy arrays, data frames. And I'm going to show a small little demo just doing like a group by operation on a Redshift cluster that we're running. Oh, also, I wrote this little IPython extension called Auto Time, which basically will run the time of anything you run, it will time. I always call, let's see, sorry, let's get rid of that guy. I always end up calling time after I've already done something that's taken a long time, so I kind of wanted to just have that automatically happen. And then I'm going to talk about Odo in a second. So one thing what's that? Oh, sorry. Oh, use auto time. It's kind of fun. Okay. So the way that let's see, do I still have this? Okay. The way you can initialize like a data resource in Blaze is to actually say, let's see, so you call resource. That's actually from Odo, but all these things are actually directly importable from Blaze. You say Redshift. I'm going to have to go get the URL in a second. Let's see. I have this in my history probably. There it is. Okay. This nice URL. Oops. Okay. This is actually a SQL Alchemy engine that I can now sort of do stuff with. Blaze has this object called data. It's actually a function, but oops, I import it. Okay, that didn't go well. Let's see. All right. Connection issues. Joy. Yeah, that's not. It will use that automatically. All right, so I have a backup. I'll use my sort of local Postgres install. There we go. Okay. Right. So one thing that's kind of nice about Blaze and Odo is that you can explore your data set or your database, right? So I have a couple of tables in here, NYC, NYCPG bulk load, and you can sort of access them all with dot attribute access, which is kind of nice. Another thing that Blaze does for you is inspect the D shape to see what operations are possible. So you won't be able to do things like take the average of a string column. In pandas, if you say dot on your series, it's going to tell you, basically the entire API for all types, no matter what the column is. Blaze limits this for you, which is kind of nice. Okay, so that actually just sucked out a little bit of the data from SQL Alchemy and then shoved it into a data frame and then called like repr HTML on it. You can also look at the whole table. You can do group by operations. So you could say like DNYC passenger count. Actually, so there are some funky values in passenger count. So let's look at the max of that guy. 6 passengers in a taxi. That seems weird. There's actually, this is a subset of the data set, but in the full data set, there are some that have like 9, which is strange. So let's get a subset of that. We'll get the data where the passenger count is less than or equal to 4. And then we'll do a group by on that thing. Let's say how many passenger count, and then we'll say, let's get the average tip. All right, so it didn't actually compute in 5 milliseconds. It just built up an expression. When I repr this thing, it will actually trigger computation. Okay. So yeah, it took like 100 milliseconds. So you can and this sort of expression, this expression will work basically on anything that that this data function accepts, which is like a SQL Alchemy URI, a data frame, list of tuples. You can roll your own thing if you want. And so that's sort of the demo there. Now, let's get back to this. So one thing that is somewhat annoying about having all these systems is like, well, I need to get between them, right? SQL Alchemy is a fun case of stuff that when you get out the actual result, let me just delete this cell. Let's call this X, and we'll say result. All right, so I have this like selectable that I'm going to call execute. Now, what is that thing there? That is a proxy of some kind, a result proxy. Okay, maybe so that's fine. That doesn't have anything. Now, that basically got all the results and sucked them into memory. Now, let's get everything out. Oh, a list of tuples. Not so fast. Oops. Okay. Let's see. Oh, we'll just do this guy. It's a row proxy. It's not actually a tuple. So where do the proxies end? They don't. This is sort of, I actually really like SQL Alchemy. I think it's a great project. But sometimes when you're doing stuff, like when you're developing against a library or using it in some kind of developer capacity, you feel like you never actually get down to a Python object. So please just give me a data frame. And this is where Odo comes in. Odo is a library for turning things into other things. at its most basic, super generic level. It was factored out from Blaze in December, maybe, of 2014. What's that? 13. Okay. All right. So whenever I would tell people what Blaze was, they would say, oh, it's a set of converters. And I'd say, it's not really a set of converters. So is LLVM, right? It's just a set of converters. Odo handles like a very, very large variety of conversions, and a very, there's interesting sort of paths you can get through the sort of network of conversions that I'll show you guys in a second. But first I want to sort of get a list of all the containers in the PyData ecosystem. So you guys got to help me out, because I don't know them all. I started off by just saying a list. So just shout out like different containers. Data frame.
Array, numpy array.
Numpy array.
Order dict.
Order dict. Master array. All right, so all NumPy and pandas stuff. So there's also things like Spark data frames, custom things that people sort of roll on their own. And we want to move between those things. SQL Alchemy has a large variety of things that you can sort of move between, right? There's like tables, selectables, select statements. Okay, Django result sets. We don't support that, but we could. You could write that. Is that Jeff?
Yeah.
Okay.
Does sets count?
Yes. Oh yeah, we support sets for sure. We use that a lot in testing because a lot of these systems don't guarantee the order of results. PySpark in particular. So simple things, list tuple. That's kind of a no-brainer. But we also do sort of more crazier things like converting a CSV on Hive to Parquet. That takes a while. I sort of like to think of it as CP with types and specific to sort of PyData ecosystem things. And it lets you do things, it lets you go from X to Y in the most efficient way without explicitly writing down each conversion, which is kind of a nice thing. So before, when Odo was in Blaze, we had like sort of the pairwise listing of all the possible conversions from each particular type to every other type. That got really annoying. And in the case of something like data frame to Hive, there's a step in between that sort of is easy, but you may not know every single step. So has anybody done this, like without Odo, trying to stick a data frame onto into a Hive table? No? Okay. When going from data frame to Hive, you usually know each step, right? I know how to do data frame to CSV. I know how to go from CSV to Hive. Odo sort of connects the dots for you automatically. And in a few minutes, I'll sort of show you how that's done. And there's essentially one function if you're a user. It uses multiple dispatch to figure out types in certain cases. In this case, it will actually use that. So it accepts sort of different types as well as strings that specify like a SQL Alchemy URI. So there's essentially one thing to remember as far as function calls. Let's sort of go through the steps for something that's a little bit more involved than sticking a data frame onto a Hive cluster. We have some JSON in an S3 bucket, and we want to shove that into a Postgres database. Let's say it's a local Postgres database. Does anybody have any, like, how would anyone do this? Like, does anyone want to just say, like, how they've done this or how they might go about doing this? No? Okay. So this is the sort of approach that I might take. I would bring down my S3 file into a local temporary file. And this is like how you do it with Odo, after you've done your authentication and so forth. Get your bucket, you get contents of file name, and I've got it in a temporary file. Now I have to load the temporary file into a data frame with pandas read JSON. Let's assume my JSON is sort of like line delimited and nicely formatted. Doesn't have nested data. Then I have to call that data frame to read CSV, to CSV. Then I have to take that CSV and I have to say copy T from blah, 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 something, something, something. Right, so you don't just stick it in there. But, well, you do, because you have Odo, and Odo lets you do that. You can suck down that S3 file, it shoves it into whatever temporary file your system, wherever your system puts temporary files, and then you say, okay, I want it to go into this table, and it will just do that. So like I said before, each step is usually easy, okay, but the whole thing ends up being like kind of annoying. How does it actually work? What's going on behind the scenes? There's a network of conversions. So when you define a conversion function, there's a decorator that basically shoves in a tuple of the types, the conversion pair, into a dictionary, and multiple dispatch sort of looks that up whenever you call essentially Odo. This is an example of a single node and, sorry, not a single node. It's an example of the pandas data frame subgraph. So I basically took pandas data frame, looked at all the things that were close to that in terms of how many nodes apart they were. So you can see data frame is connected to, is connected to quite a few things. Right? So it's connected to series, of course. Fixed is something that we use to append and read from HDF store. There's a chunking mechanism built into Odo. And then, of course, numpy arrays also talk to like lots of stuff. So we support that as well. And the full Monty is pretty big. So you can get some kind of interesting paths when you trace through these things. There's also a cost mechanism built into Odo. When you define conversion, you can say how expensive it is to go through a path. And you can extend it basically without having to talk to me or anybody else working on Odo. You can define your own conversion function, and Odo will just pick it up and put it into the graph. Let's see. I think that is it. Right. So you can conda install it. We just had a release 2 weeks ago. Lots of bug fixes. There's documentation at blaze.pydata.org, odo.pydata.org, and we would love some contributors as well. Currently, I'm the only person working on Odo in a fullish time capacity. So yeah, happy to take questions. Yeah.
What happens like somewhere along the route you lose some piece of metadata? Like, something doesn't properly get serialized to CSV, but and you want to take a different route maybe that doesn't lose that.
So you have to write your own sort of custom function to do that. Odo doesn't handle, so in certain cases it's very difficult to preserve metadata. One case is like time deltas. So Python's time delta object only has microsecond precision, whereas NumPy has like down to attoseconds or something like that. So in those cases, we don't preserve the metadata.
You just write your own custom object.
Yeah. Yes.
So how hard was it to write all these different converters? Was each one basically its own separate, gruesome battle? And, or was there like one generic method that you just had to tweak now and then to get it to convert?
That sort of depends on the support of that library for going to that particular object. But in certain cases, we leverage the graph that lets you sort of, like if something knows how to go to a numpy array, and that numpy array knows how to go to the other thing, but the original thing doesn't know how to go to the other thing, then it will just take that path. So not hard in some cases. It's sort of, there's one sort of core thing that does the iteration through the graph, looping through and just calling every conversion function until you reach the end. But
And that brings up another question. In the case of like going through a numpy array, that would mean that your data would have to fit within memory to pull that off, right?
yeah, so there's no automatic out-of-memory conversion unless you start with something that's already out of memory. So if I have a CSV file that doesn't fit into memory, it will chunk into something. Like if you're going to an in-memory container, then there's nothing that we can do, right? You're saying like read this into memory. But if you're going from like CSV to H5Py, then Odo will chunk into the H5Py file automatically. And in general, on the graph, the red nodes are basically indicate that those things are out of core. And so once you end up in one of those red nodes, Odo will drop out all the things that aren't out of core. And we'll try to do the conversion within that path, within that graph. There's another hand somewhere.
I think you answered it, but so
Okay.
if you're just to specify, so if you're out of memory and you're going to another out of memory and there's a path, it will take that path even if it's more expensive or there's more links in the chain than going to an in-memory and then direct.
Yeah, it will actually just take that subgraph and use that to compute the shortest path. So it drops off everything else that isn't out of memory. Was there another hand? Yeah.
Me again, or someone?
Oh, sorry, the guy in the back, blue shirt.
Okay, this might be a pretty narrow question. I was using Odo last week, and I had imported something using the Blaze data function. And then I tried to use Odo to save it off the CSV, and I lost my headers, basically. And I couldn't figure out how to make it keep the headers on that table.
Were you using MySQL?
No?
Okay. So MySQL doesn't officially support writing headers. It's kind of a weird thing. Anyway, that sounds like a bug, but where was it coming from?
It was coming from a CSV file, and I would bring it in, and then I would mess around with it, and I'd try and save it back. And when I saved it back, it tossed the headers.
Okay, sounds like a bug. Let's talk afterward. Yes. So yeah.
So someone is using pandas for something. When would you not use Blaze? Because it sounds like, okay, like a super interface that allows you to do more things, more channels, more data sources. But when would you not use it? I mean, is it almighty powerful that forget pandas and you cannot use Blaze instead?
So Pandas has a lot of API that Blaze will probably never implement, just because Pandas is uber magic, especially around group by apply and just apply in general. So another case is resampling functionality. Blaze could grow that. But as of right now, you can't really do resampling in Blaze. And you can do that in Pandas.
So is there like a high-level kind of line that you would say, this is what you should not expect from Blaze? This is what you should expect from Blaze?
So I would say most relational database things are there. The big exception being window functions. as far as pandas goes, there's just like a lot more API in pandas that Blaze will probably never expose. One nice thing about it is that if you wanted those things and we aren't going to do them, then it's certainly possible to just like scratch your own itch without like sort of affecting the core of Blaze and but allowing you to have maybe something custom. So yeah. Did you have another question?
Yeah, so when it decides what route to take, is the cost on all those edges just the time?
No, it's kind of a unitless cost number. You just sort of assign like large if it's costly, smaller or less costly. It's just like an ordinal scale.
So if I wanted to find my own cost, I don't know if I'm trying to optimize for some weird edge case like memory or something, can I define my own cost to the edges on this graph?
Sure. Yeah, you just give it a number. You just like in the convert decorator, you say cost equals something, like a number. Yeah, it takes the shortest path through the graph. Casey.
Phil, does it tell you when you run Odo, if you're using it for a while and trying to optimize this or that, will it tell you which way it went through the graph?
No, but there's a way to get that information. So convert is like an instance of a special class that has a method called path. You give it the starting node, the thing you want to end up at, and it will give you it'll basically give you a list of tuples where it's conversion path and then function. Or so type A, type B, function, and then it'll just keep giving you that until it gets to the final edge. Cool. Any other questions? Yes. Sorry, can you just repeat it?
Is there a performance cost when you're using Blaze instead of
There's a small overhead to the like Blaze interpreter, but it's like tens to maybe ones of milliseconds. Most of these systems, there's going to be a large cost involved in serializing stuff, with the exception of like numpy and pandas sometimes, or most of the time. But yeah, so it's a pretty small cost. Yeah. Yes, sometimes. There's a path for numpy arrays. The data frame from pandas stuff, I wrote that, and I haven't put it into Odo yet. But that would be really, really easy. In fact, a new contributor could probably do it. Any other questions?